So let's continue our comparison. Last time we talked about multiplication versus subtraction. Let's go ahead and let's look at multiplication and division here. So we're going to use the same problem twice. And again, it's all about just the technique again. So let's go after x squared plus 4x minus 21, all of that over x squared minus 6x minus 16. Let's multiply that by x squared minus 8x plus 15, all of that over x squared plus 9x plus 14. So, much like we saw before, anytime we're dealing with these trinomials, especially when they're quadratics there, that second power, factoring is involved here. And that's kind of like your number one go-to. Even if you're like, I don't know what to do. Factoring is always the place to start at. So, hit that pause button, see if you can factor all three of those trinomials. And before we say that there, as going further, is you should be kind of going, yes. And why is that? Well, not because of your love of factoring, but they're all x squareds. So you should be able to jump right to that factoring here. Hit that pause button, see what you can do. All right. So, like we talked about, just focus on the 21 here. So I'm at 7 times 3. Yeah, 7 times. Oh, and I can do 7 minus 3 to get my 4. So there we are. So 7 minus 3. So that means the x, all right, plus 7, and then the x minus 3 gets me there. All right, let's drop below. The 16. 4 and 4. No, that won't get me 6. 8 and 2. 8 minus, yep, there it is. 8 minus 2. So I've got me an x plus 2 and an x minus 8. I was going to say the 8 first, but then I realized I wanted it to be negative. So I needed more negatives, and 8 would give me more negatives than 2 would give me negatives. All right. 15. 5 and 3 is all that jumps. That does get me to an 8. All right. But I need a negative 8. So I need them both to be negatives. And the idea here is negative 5 times a negative 3 is a positive 15. All right, and then drop down below to that denominator. I see a 14. All I'm thinking about is 7 and 2, and yet that does add up there to that 9. So x plus 7, and then x plus 2. All right, and multiplication is the one we like the most because it requires the least out of us. We factor, and then we start slashing things. So I'm looking for anything that's upstairs and downstairs. They could be right above each other. They could be on that diagonal. It doesn't make a difference here. So I'm looking. I see me an x plus 7. All right. I'll go fancy here. All right. I see me an x plus 7, so I can wave goodbye there. And then I think that's it. I mean, I see an x plus 2 down there, but that's not going to get the job done. They're not above and below x minus, yeah, no, that's it. So, the thing about this is when you write out your answer, you're just stacking them all next to each other. X minus 3 times x minus 5 times x minus 3 all over x plus 2, x minus 8, and then x plus 2. I tell you what here, let's get fancy though. Let's get real, well, okay, maybe not real fancy, but just sort of fancy. Do you see how we have an x minus 3 and an x minus 3? Yeah, they repeat. So because they repeat, we could actually write down x minus 3, squared. Yeah, exactly. And then so down in the denominator, the x plus 2's repeats. So I could say x plus 2 and then squared and then x minus 8. So, again, a little cleanup there, just something worthwhile to kind of talk about. All right? Okay, so what if it was a division problem? Okay, if it was division, what we can end up doing here is kind of putting it in reverse, all the way. I'm gonna go right up here and kind of continue from here. So the beginning part stays the same. Like, hey, we can factor. The thing that we want to keep in mind, though, is that when we do end up factoring here, we do need to make sure that that second fraction, we do end up flipping it. So that's that whole multiplying by the reciprocal. Yeah, all right. So when I'm looking at this, looks like I lost them there. So x minus x plus 7, x minus 3, and then x minus the 8, and then the x plus the 2. What ends up happening here is on this right-hand side, well, let's go all official here. Remember, we're going to change it to a division problem. This guy simply gets flipped. And then because it becomes a multiplication problem, all the rules simply stay the same. So, let me get this out. Sometimes I think it just might have been easier if I started over. All right, so the idea is we still have the x plus 7. We still have the x minus 3. All right, nothing there, it changes. I still have the x minus 8. I still have the x plus the 2. But over here, that x minus 5, gets moved downstairs. That x minus 3 gets moved downstairs. The x plus 7 moves upstairs, and the x plus 2 moves upstairs. And now it's a multiplication problem. And so the idea here is now I'm just using my multiplication rules. So in the division problem, all we have to do is rewrite it. And now I'm looking for any one. I'm like, oh, x plus 2. Okay, bye-bye. X minus 3, x minus 3. There's my x plus 7's upstairs, but that's not going to do anything. The x minus 8, no match there. So yeah, so we've got them there, and all we're going to end up doing here is trying to find what the problem is. Yeah, there it is. All right. All we're going to end up doing here is writing down what we've got left over. So I've got my x plus 7. I've got my, another x plus 7. Let's just jump to it right away. Yeah, let's try this square. Now again, if you don't do that, it's okay. It's just a good thing that I had an opportunity, so it's welcome to talk about it. But it shouldn't make a difference. And there we go, x minus 5, and we're done. So multiplication, factor, start slashing things out. Division, factor, but we have to rewrite that problem. If you want to rewrite the problem first, that's fine. The main thing there is you've got to flip that second fraction before you start using your multiplication technique. All right? That's it.